All right, so one of the first and most critical skills that we need to develop in this unit is the ability to identify the forces that are acting on an object. So I'm going to give you guys a simple system here. The system that we're talking about is a car that's being pulled upward up a hill by a rope. And the system that we care about is the car. Everything else is part of the surroundings, things that are acting on the car, but we don't care about them as much as we care about the car itself. So when it's time to identify forces, you need to draw a circle around the system, or in this case, around the car itself. All right, done. And then the next thing we do is we start identifying the things that are in contact with the car. And every point of contact is a potential force that could be acting on the vehicle. So I'm going to start identifying those. The first one, I have it right here. You can see that the rope is acting on that. And the name for forces called by ropes that we'll use in this class is called tension. Usually, if we're talking about tension, I'll use one of two different variables to represent it. I'll either just use T with a vector arrow over it, or I'll use F sub T, as in like the force of tension. So either just tension or force of tension. And this is what's called an applied force. Any applied force is generally not something that you can calculate, like the magnitude of. It's something that you have to know what it is, or you can figure out what it is by knowing the other forces acting on it. But there's no formula for applied forces because you could pull on a rope with 100 newtons or 50 newtons or whatever number you wanted and still be applying, you know, anything between 50 and 100 and any number. It's basically just the choice of whoever's setting up the problem or whoever's doing the pulling. So that's tension. And if I wanted to write the tension in an official physics way, this is how we'll be writing all of our forces for the first week of this unit. We're going to write it as a variable to represent it. I'm just going to use the T right here, although you could have used the F sub T if you wanted. And then I'm going to say the type of force, so the tension, the type of force, this is a contact force, meaning a force that's coming from a direct push or pull acting on the object. These contact forces are always just those macroscopic versions of electrostatic, but we're going to call them contact forces. And then I'm going to say by what and on what. So this is a force of contact, a force of tension, which is a contact force by the rope on the car. And we're going to track all of these. And we need to get good at writing these things out because it's going to make things much easier for us later when we start learning some of the laws of motion. Okay, some other points of contact. We have down here, I'm not going to draw one for each wheel because they're both coming from the same spot. So I'm just kind of drawing vaguely in the middle. But down there, we have a force acting on it from the surface that it's pushing against. And there's actually two forces that are caused by surfaces. There's a force called the normal force. Oh, yeah, that's ugly. Handwriting's terrible. Sorry, guys. There's a force called the normal force, and I'm going to use either like N for normal force, or maybe I'll use F sub N to represent normal force. Those are the two most common ones. You always know that a normal force, and you need to memorize this, it's always perpendicular. And by perpendicular, I mean to the surface. So the normal force is pointing straight up perpendicular to the surface, meaning that it would be going at roughly that direction there for the normal force. So that's always normal force. And if I'm writing it in our official physics way, I'm going to use N to represent it. And then I'm going to say what kind of force it is. It's a force of contact by the surface on the car. You'll notice that every one of ours says on the car today. That's because we're doing our job right and only identifying the forces on the car, which is our system. If you start writing a force that says on something else that isn't your system, you're doing forces that don't matter to our current problem. And that's why we're doing it with like writing all this stuff, is to get us in the habit of only identifying the right forces. Okay, the other force that's caused by surfaces is the force of friction. Friction is going to be a little bit like air resistance in that we're going to ignore it um, a lot of the time, but not always. And we'll always state when we should ignore it. So you can write force of friction like that. That's how I generally write it, force of friction. But some other ways that you might see it is you might see this right here, force of mu s or force of mu k, and I'll talk about where those are coming from later on. Or the text or the AP exam sometimes just writes it as a lowercase f vector. That's the frictional force. And just like we always, these two surface forces, they act in specific directions. Normal is always perpendicular. Friction is always parallel. It's always parallel to the surface and opposite the motion. So writing it in the official way, I'm going to say the force of friction. The type of force this is a contact force because friction only exists if things are touching each other. It's again by the surface because there's always two surface forces because it can always act perpendicular and parallel, and it's acting on the car. And just like that, we've now identified all of the forces acting on the vehicle. There's this one from the pull and this one on the ground. You can see that nothing else is touching the car. So the only other forces that we have to identify are the forces which act on it over a distance. And for us, that's always going to be gravity. Anytime that you think you've finished this, you always have to add the force of gravity. I should write force of. The force of gravity acting on this. Force of gravity can be written a couple different ways. I will almost always write it like that, as in force of gravity. Oops. But wait, the textbook and the AP exam will sometimes call the force of gravity by a different name, which is weight. That's worth writing underneath it because they are synonymous. When you're talking about the weight of an object, you're not talking about its mass. You're talking about how strong the Earth pulls on it. And force of gravity and weight are the exact same thing. It's weight and it's always down, as in straight towards the center of the Earth. And this is our only long range force. Any other ways to write it? Oh, one more way to write it. I'll often just simplify it. This is the formula for weight on Earth, mg, and I tend to just skip calling it force of gravity and just write the equation in more often. So writing this in our official way, we're going to say force of gravity. This is a field force because it's acting at a distance. And it's by the Earth itself. All of the mass of the Earth is pulling down on this, not the center of the Earth, but all of the mass of the Earth, and it's acting on the car. So that's how we identify forces. My challenge for you, if you want to try and do a couple more on your own, is imagine that we have a baseball that's been thrown through the air. So it's flying through the air. Can you identify how many forces are acting on that? The next one that I could ask you guys about is what if we have two people playing tug of war? Yeah, they're playing tug of war. Can you identify which forces are acting on the rope? So I want to know the forces on the rope, the forces on the ball. And if you guys can identify those forces accurately and write them using these rules, you'll be in good shape. And I'm just going to pause the video real fast and I'll fill them in. So pause it and try it on your own. Okay, and there are the answers. There's only one force acting on the ball. It is just the force the field force of the gravity by the Earth on the ball. There's no force of throw here. Don't make that mistake, because even though it's moving, no one's touching it. So if there's no push or pull, there's nothing touching it, then there's only just the field force of gravity. Then for the rope, there's F1, which is the contact force from the first person, F2, the contact force from the second person, and force of gravity because it's still on Earth. All right, that was force identification. Thank you and have a great weekend.